Assume that we have the law of exponents proven that x to the r times y to the r is equal to x times y to the r if x and y are both positive real numbers and r is any integer. Let's carefully show that this property works even if r is a rational number. The proof that it works for positive integers is fairly straightforward. Just you multiply x to the r times y to the r, that's going to be x times x times x times x times y times y times y times y, then rearrange terms so you get x times y times x times y times x times y r times. So the proof for positive integers is fairly straightforward. The proof for negative integers is going to be based very much on the proof for positive integers, just using the definition of what it means to raise a number to a negative power. So I'm not writing it on the screen. We'll assume that we've gone that far in our exploration of the law of exponents. Let's now prove that the property works if r is rational. And to do this, let's remember a couple of key definitions. That x, well, let's start with this. The qth root of x is the unique positive number y, so that y to the qth power is equal to x. So when you see this term, the qth root of x, where x is a positive number, it is the unique positive number, so that when you raise it to the qth power, you get the original number back. Also, we want to keep in mind that the definition of x to the p over q, that's defined to be the qth root of x, then we raise that to the pth power. So we want to keep that in mind. Those are the two basic definitions that we have that we're going to use in the course of the proof. So proof. Let r be equal to p over q, where p and q are both integers. Okay, now let's take a look at the right-hand side and then the left-hand side of the statement. So by definition, x times y, all raised to the p over q power, by definition, that is equal to the qth root of x times y raised to the p. Now the qth root inside the parentheses is by definition a positive number, and so this must also, when I take a positive number and raise it to the pth power, it must be positive. Okay. Also, let's see what happens if I take x times y to the p over q power and then raise it to the qth power. Okay, so by definition, the thing inside the brackets is the qth root of x times y raised to the p, and then I take that whole thing and raise it to the q. So all I've done is change the thing that's inside the brackets. Now, the thing inside the parentheses is a positive number. So if I have a positive number to the p to the q, that is equal to the same positive number raised to the p times q. Okay, that is also equal to the same positive number raised to the q, then to the p. And by definition, if I have a qth root of a number and raise it to the q, then the qth root of a number raised to the qth power is the original number. So I must get x times y raised to the pth power. Okay, so what I've said is that x times y raised to the p over q is positive. X times y to the p over q to the qth power is equal to x times y raised to the p. And so by definition, x times y to the p over q must be equal to the qth root of x times y to the p. The number on the left-hand side is positive. The number on the left-hand side, when I raise it to the qth power, I get x times y to the p. And so by definition, that number must be the qth root of the thing that I end up with when I raise it to the qth power. So that is the left-hand side, x times y to the p over q can be written as this. What I will do now is show that the left-hand side, the same thing happens. So to do that, let me raise the part in blue to the top of the screen. And so I have some more room to write on the bottom. So let me lift this up. And let's now examine what happens for the second part. So to do that, let's take a look at, so next, x to the r times y to the r, that's equal to x to the p over q times y to the p over q. Again, by definition, x to the p over q is the qth root of x raised to the p, and that's times the qth root of y raised to the p. Now both the things inside the parentheses are positive. They're qth roots. And so by definition, the thing in the parentheses is positive. And so when I take both of them and raise them to the pth power, then multiply them to each other, they're both positive. The product is positive, so this product is positive. Next, I will show that when I take that product and raise it to the qth power, I will get the same thing, x times y to the pth power. Let's take x to the p over q times y to the p over q to the qth power. That's equal to, by definition, the qth root of p of x to the p times the qth root of y also to the p, and then I need the qth power of that. So like before, I need to kind of carefully rearrange things so that the qth root and the qth power go next to each other. Now the way that we can do this is because the qth root of x is positive, qth root of y is positive, p and q are both integers, and so therefore if I have positive number to the p times positive number to the p to the q, this breaks up. And so I may write this as the qth root of x to the p to the q times the qth root of y to the p to the q. Now that's by the law of exponents, where p and q are both integers. Okay, so now I will manipulate these powers in much the same way that I manipulate the powers up here in blue. I have a positive number raised to an integer raised to an integer, and so the integers multiply. So same positive number raised to the p times q. And once again, same positive integer, q through the y, to the product of the two powers. Okay, continuing the calculation over here to the right, that's equal to the qth root of x to the q to the p, because once again, q and p are both integers, and so q times p would be p times q. Same thing for the other one, q3 root of y to the qth power to the p. And so this becomes, as before, qth root of x to the q becomes x to the p by itself, then y to the p by itself, and then by the ordinary law of exponents for integers like p, this is equal to x times y to the pth power. So at the left-hand side, x to the r, y to the r is positive. Also, if I raise it to the qth power, I get x times y to the pth power. So x to the r, or x to the p over q, times y to the p over q is equal to the qth root of x times y to the p also. And clearly, if this thing is equal to the pth power, the qth root of x times y to the p, this other thing is equal to the qth root of x times y over p, so that means that the two things are equal, and so that x times y to the p over q is equal to x to the p over q times y to the p over q, which ends the proof. So this is a very careful way of proving the law of exponents for rational numbers based on the law of exponents for integers.